Okay student, in this video I'm going to explain about the combinations of capacitor in series. So let us look at the arrangement first. As we can see in this figure, we have three capacitors. This is the first capacitor, second and third capacitors. So these capacitors are connected in series. So when I say series combination mean the negative plate of the first capacitor is connected to the positive plate of the second, the negative plate of the second to the positive plate of the third, and so on. So if we are doing the connection in this way, then we say that the capacitors are connected in series. Alright? So now we will imagine in this way that the two free ends of the capacitor, like the positive plate of the first capacitor and the negative plate of the last capacitor, are connected to the potential difference V. Right? So let's say that the capacitance of these three capacitors, they are C1, the capacitance of the second capacitor is C2, the capacitance of the third capacitor is C3. Right? Now, apart from that, this potential difference V, which is actually the total potential difference which is applied across the combination, right, it is divided into three potential differences. So the potential differences across the first capacitor is V1, the potential differences across the second capacitor is V2, and the potential difference across the third capacitor is V3. Okay, so if this potential difference from the source here, let's say it produces a charge Q, or a charge Q, let's say it is emitted by the source. Now that charge Q, right, will be flowing through each capacitor here. So therefore I have shown here that the first capacitor, right, it is having a charge Q. The only difference is that the positive plate, it is plus Q, the negative plate is minus Q. Similarly, the second capacitor is having a charge plus Q and minus Q. So likewise, third capacitor also is having a charge plus Q and minus Q. Right? So now, the potential difference across different capacitors, right, it can be obtained using the equation of the capacitance, where C is equals to Q upon V. So therefore, if you find out V from here, you will get V is equals to Q upon C. So this is the formula for the potential difference of the capacitor. So using this formula, we can say that the potential difference of the first capacitor, that is V1, it should be equals to Q. The capacitance of the first capacitor is C1. V2, Q by C2, V3, Q by C3. So these are the potential difference across the three capacitors. Now, it is clear from figure also that this applied potential difference across the combination, it is actually equals to the sum of the potential differences across the three capacitor. That is V equal V1 plus V2 plus V3. Or we can say V is equals to, substituting the values of V1, V2, V3, we get Q by C1 plus Q upon C3 plus Q upon C2 plus Q upon C3. Next, taking common Q, inside the bracket you'll have 1 by C1 plus 1 by C2 plus 1 by C3. Right? Taking Q this side, you will get V by Q equal 1 upon C1 plus 1 upon C2 plus 1 upon C3. Okay? So look carefully here. This V is actually the applied potential, and this Q, it is the charge which is given by the source. So this is nothing, it should be equals to the reciprocals of the equivalent capacitance. So when you combine three capacitors, then the equivalent capacitance will be, let's say it is CS. So because again, right from the formula, C is equals to Q by V, or I can say, right, this V by Q, taking reciprocal of this, you'll get 1 upon CS. So therefore, right, this 1 upon CS is equals to 1 upon C1 plus 1 upon C2 plus 1 upon C3. So this is the formula for the equivalent capacitance of three capacitors when connected in series. Okay, so with this formula you can extend for any number of capacitors. Like if you have n number of capacitor connected in series, then the equivalent capacitance in that case will be 1 upon C1 plus 1 upon C2 plus 1 upon C3 plus dot 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 up to 1 upon Cn. So this is the equation for the equivalent capacitance of n number of capacitors connected in series. Alright, now a point to be noted here is that the reciprocal of the equivalent capacitance, okay, this is the reciprocal of the equivalent capacitance, is equals to the sum of the reciprocals of the individual capacitances. And point number 2, the equivalent capacitance is smaller than the smallest individual capacitance. That means if I have C1 equal 1 microfarad, C2 equal 2 microfarad, and C3 equal 3 microfarad, then find out the equivalent capacitance. In that case, you'll get 1 upon CS is equals to 1 upon 1, 1 upon 2, 1 upon 3, or find out the LCM. LCM is 6, so here you'll get 6 plus 2 times 3, 3 times 1 means 3, here you'll get 2, and this is 9, 9 means 11 by 6. This is 1 upon CS. So just CS will be, taking the reciprocal of 1 upon CS, which is 11 by 6, so now CS will be 6 upon 11. So when you divide this, you'll get 0 point something, okay, right, 0.1 something, okay. So this 0.1 something, it is actually the value of the equivalent capacitance. So hence we conclude that the equivalent capacitance, it is always smallest, smaller than the smallest capacitance here. What is the smallest capacitance among the three capacitors? 1 microfarad. But we find here that the total capacitance, it is lesser than this. So that is the meaning of the point where the equivalent capacitance is smaller than the smallest individual capacitance. And a third point to be noted is that the charge on each capacitor here is same. If the charge of the first capacitor is Q, here also will be Q, here will be Q. And the potential difference across any capacitor is inversely proportional to its capacitance. That is clear. Okay, see, because Q is constant means the charge on each capacitor is same, so that means this is constant. So this potential difference, it depends only on the capacitance of the individual capacitors. So therefore the potential difference is inversely proportional to the capacitance of the capacitors. So these are the points which you have to be noted regarding the series combinations of capacitors.